All right, if you would please grab out your Simply a Similar review, and we're going to go through every question together. All right, so the figures are number one, the figures are similar. Determine the missing measure. So I've got angle A, B, C, P, Q, R. All right, the first one is I want to know what is the measurement of angle A, meaning I want to know what is the degree number of angle A. Well, I know that A is corresponding to P. Well, P and A still don't have a number. I also know that all of my angles inside of a triangle are 180 degrees. So I'm going to do angle B's measurement of 64, add angle C measure of 49, and I'm going to add these numbers up together. 9 plus 4 is 13, 10, 11, and I'm going to get 113. And then I'm going to take that number and I'm going to subtract him from 180. So 760 to get angle A is 67 degrees. All right, what is the measurement of angle Q? Well, angle Q is corresponding to B, and my angles are equivalent, and B is 64 degrees. All right, measurement of A to C. So I want to know what is this measurement here. Okay, well, I know that it's 22.5 to here. I'm going to use this as my ratio. So 23 over 46 is equal to 22.5 over x. Well, I know going from here to here, from small to big, it's times 2. So I'm going to go from small to big, and I'm going to multiply it by 2. So 22.5 times 2, 0, 4, 5, and then 4, 1 decimal place. And from A to C, it is 45 inches. What is the measurement of A to B? So I want to find this one. Well, I know that from 23 to 46 is times 2. By similar figures, my sides are proportional, and that also means that when I multiply one side by, I have to multiply every single side by the same number. So I'm going to do 19 times 2, 18, 2, 3, and I'm going to get 38 inches. 38 inches. All right, number 2. Circle all the rectangles that are similar to rectangle A. Show all the work to prove they are similar or not. All right, so rectangle A is 6 over 8. Okay, and let's see, let's look at this rectangle. It is 18 over 24. Well, how do I get from 6 to 18? I'm going to multiply it by 3. And it's 8 times 3, 24. So, yep, that rectangle is proportional. All right, let's try the next one. So I'm going to start with 6 over 8 again. And I'm going to have 12 over 14. Well, 6 times 2 is 12. Well, is 8 times 2 14? No, so this one is not proportional. All right, let's try this rectangle. I'm going to have 6 over 8. Now realize that 6 is my short side and 8 is my long side. This rectangle has been turned on its side, and I see that 12 is my short side, so that's on top, and 16 is my long side, and that is on bottom. There we go, 16. All right, 6 times 2 is 12. Well, 8 times 2 is that 16, and it is. All right, and then one more. I have 3 over 4, so 6 over 8, and then I've got 3 over 4. Well, I know that from 3 times 2 gets me 6. Well, does 4 times 2 get me 8? And it does. Okay, and it does. All right, number 3. All right, number 3. The height of a building in Chicago is 1,200 feet or 1,200 feet. Casey made a scale model of the building at a scale of 1 to 200. Calculate the building height of her model in inches. Okay, so I'm going to have model over actual. I'm going to start with my scale of 1 over 200, and I'm going to set it equal to my other ratio. And I know that I'm at 1,200 feet, and I want to find the model. So 1,200 feet is the actual, and my model is unknown. All right, going from 200 to 1,200, it's times 6. And what I do on bottom, I'm going to do on top. Well, 1 times 6 is 6 inches. 1 times 6 is 6 inches. All right. The ratio of 2 adjacent side lengths of a rectangle are 2/3. Which of these could be the ratio of 2 adjacent side lengths of a similar figure? All right, so I've got 2/3. Well, I know that 2 times 2 is 4. Is 3 times 2 9? No. All right, let's look here. 2 times 2 is 4. Well, is 3 times 2 3? Nope. Let's take a look here. 2/3. 2 times 1 is 2. Is 3 times 1 6? Nope. So I'm going to mark those out. All right, let's take a look. 2/3. Well, 2 times 2 gets me 4. Is 3 times 2 5? Nope. And then 2/3. Well, 2 times 3 can get me to 6. 3 times 3 can get me to 9. So 6/9 is another possible choice for us. All right. Jeremy is driving to a friend's house that is 72 miles away from home. The scale on Jeremy's map, is 1/2 inch is equivalent to 8 miles. How far is it on the map from Jeremy's house to his friend's house? All right, so I'm going to have model over actual again. And I have it as 1/2 inch is equivalent to 8 miles. Well, I know that 8 is my actual. 1/2 is my model. And I'm going to turn 1/2 into a decimal of 0.5. And I'm going to set this equal to 72 is my actual on the bottom. Well, 8 times what can get me to 72? And 8 times 9 can get me to 72. So I'm going to do 5 times 9. And that's 45. Well, I have one decimal place. So on my map, it's 4.5 inches. 4.5 inches. All right, number 6. I'm sorry, it's really small. If the scale factor is 5, the measure of the corresponding angles of the image will be congruent to the original angle measure. Just because I scale my model or my figures up one size or the other does not mean my angles will. My angles will stay the exact same measure. All right, number 7. The driving distance between Chicago and New Orleans is 900 miles. Xiaomi is using a road atlas that contains a national road map scale of 1 inch to 150 miles. What is the distance between Chicago and New Orleans on the map? All right, model over actual. So my scale is 1 inch over 150 miles. I know that I have traveled 900 miles in all. And how far did I go on the map? Well, I need to know what can I scale 150 by to get to 900. So I'm going to do the opposite. I'm going to divide the two numbers. So I'm going to have 900 divided by 150. So 150 on the outside, 900 on the inside. And I'm going to start doing my multiples. 150, 300, 450, 600, 750, 900. So 1, 2, 3, 4, 5, 6, and it should be 6. So 150 times 6 is 900. I'm going to double check my numbers. Yep. What I do on bottom, I must do on top. Well, 1 times 6 is 6. So on the map, it is 6 inches. All right. The scale on the drawing is 3 to 1. What does this mean? Okay, think about it. Model to actual, 3/1. That means for every 3 inches on my model, it will be 1 foot in real life. Now, my units of inches and feet can change depending upon if you are given your units before. I'm just saying in retrospect that it means roughly that 3 inches or 3 whatever on my model, 3 whatever units is 1 foot or 1 whatever units for the actual figure itself. All right, number 3. Or page 3, sorry. Number 9. Jan is enlarging the sketch shown on the photocopier. What are 3 dimensions this sketch could be? So I want to know what are 3 other possible dimensions that I could have for my model here. So I'm going to draw 3 more rectangles. All right, so I want to say I want to have a scale factor of 2. So that means I want to multiply every single side by 2. Well, 2 times 2 is 4. 3 times 2 is 6. All right, I want a scale factor of 5. 5 times 2 is 10. 5 times 3 is 15. All right, I want a scale factor of 1/2. So I'm going to multiply everything by 1/2. So 2 times 1/2 is 1. 3 times 1/2 is 1.5. And those are all 3 different dimensions that are equivalent to the original 2x3. All right, number 10. Gerald wanted to find the height of the flagpole at the entrance of his school. He used a mirror and he recorded some measurements on a drawing. What is the height of the flagpole? All right, so I'm going to write my ratio of distance over height, so 100 over 150, is equal distance over, oops, I did that backwards. Distance over the height. Sorry, 600 is my distance. All right, I'm going to scale. So 1 to 600 is times 6. What I do on the top, I must do on the bottom. So 150 times 6, 0, 30, carry the 3. 6 times 1 is 6. 7, 8, 9, and that is 900. So the height of my flagpole is 900 centimeters. 900 centimeters. All right. Number 11, triangle DEF is enlarged to triangle ABC. Grab 3 highlighters. All right, I'm to list the corresponding sides and the corresponding angles. So I'm going to go ahead and highlight my sides. A to B is corresponding to F to E. So these 2 sides are corresponding. B to C is corresponding to E to D. And then A to C corresponds to F to D. All right, so we're going to write that out for corresponding sides. A to B is similar to, well, I started at A, so I need to start at F to E. B to C is similar to E to D. A to C is similar to F to D. Now let's take a look at the angles. Well, angle A is congruent to angle F. Angle B is congruent to angle E. And then last but not least, angle C is congruent to angle D. All right, number 12. I have a square whose sides measure 5 inches. Okay, well, knowing a square, all of my sides are exactly the same. With a scale factor of 4, so my scale factor is 4, what would the new side lengths be? Well, knowing that my sides are proportional in my scale factor, I'm going to take 4 and I'm going to multiply them by every single side length. So 4 times 5 is 20. And knowing by a square and the properties that all the side lengths are the same, that my measurement is going to be 20 inches by 20 inches. Number 13. How can you prove 2 figures are mathematically similar? Well, my first one is same shape. My second one is congruent angles. And my last one is proportional sides. Same shape, congruent angles, and proportional sides. All right, 3 more. Number 14, use the diagram to determine below to determine the height of my flagpole. So I want to know, what is the height of my flagpole? So I'm going to do distance over height. So 2.5 over 4 is equal to 7.5 over x. Okay. And I need, what do I multiply 2.5 by to get to 7.5? So I'm going to do the opposite. I'm going to divide. So 7.5 divided by 2.5 to see what is this. Move my decimal. 25 can't go into 7. 25 can't go into 75 3 times with nothing left over. So I multiplied 2.5 by 3. And I'm going to do the same thing to the bottom of doing 4 times 3. And that's going to get me 12 feet. The height of my flagpole is 12 feet. All right, use the diagram below to determine the proportion in order to solve for x. All right, so I've got 2 triangles. One is embedded inside of the other. So what I'm going to do is I'm going to pull this triangle out, pull this bigger one out. Well, the height of my smaller one is 2.5. The height of my big one is x. The length of my small is 7.5, and the length of my entire x is 30. And I want to find the height of my triangle. So I'm going to do height over distance equals height over distance. I want to know, how do I go from 7.5 to 30? So I'm going to do the opposite to see. Cannot have a decimal on the outside, so I got to move it. All right, well, 75 can't go into 3. It can't go into 30, but it can go into 300. So I've got to find what's my multiples of 75. So I'm going to use my calculator to help me. So I got 150 plus 75 would be 225 plus 75 would be 300. And it goes in there 4 full times. So 7.5 times 4. And I'm going to do the same thing to the top. So 2.5 times 4. 5 times 4 is 20. Carry the 2. 5 times 2 is 8. Plus 2 more is 10. 1 decimal place. And it is 10 centimeters tall. The height of my triangle is 10 centimeters tall. All right, number 16. Standing next to each other, a woman is 70 inches tall, and her son casts a shadow that is 47 inches by 33 inches, respectfully. Okay. What is the height of her son? All right, so remember that when I deal with something by something, it's always width by height. All right, so I'm going to have 47 over 33, and the woman is 77 or 70 inches tall, and we do not know the width. Wait, woman is 70 inches tall. Her son casts his shadow 47 inches by 33 inches, respectfully. Hang on. Standing next to each other, a woman is 70 inches tall. Okay, hang on. I got to draw this. Woman is 70 inches tall. Okay. And her son cast a shadow that is 47 inches and 33 inches, respectfully. What is the height of her son to the nearest inch? Scrap that number because I think I made a mistake on the numbers. If you guys have any questions, please let us know.